In this video, we're going to talk about how to calculate the magnitude and the direction of the resultant vector that is formed when taking the sum of two other force vectors. And you can see the two other force vectors in the diagram shown below. But how can we find the resultant vector? Well, what we need to do is we need to break down each vector into its component form. And then we need to add the components together, which will give us the resultant vector in component form. Then we'll find the magnitude and the direction of that vector. So what we need to do is we need to determine the x component and the y component of each force vector. We'll call the x component f1x and the y component f1y. f1x is going to be f1 cosine theta. So that's 200 newtons times cosine of 30 degrees. Now, when you plug this in your calculator, make sure that it's in degree mode. Cosine 30 is equal to the square root of 3 over 2, or 0.866. If we multiply that by 200, it's going to be 173.2. Now let's do the same thing with the y component of f1. That's going to be f1 times sine of theta. f1 is 200, and then times sine of 30 degrees. Now sine of 30 degrees is 1/2. So if we multiply 200 by 1/2, half of 200 is 100. So here we have the x component and the y component of f1. So we can write f1 in component form. We could say that it's 173.2i plus 100j. So that's f1. Now you might be wondering, what is I and j? I and j are unit vectors. Now you might be wondering, what is a unit vector? Well, think of the word unidirectional. Uni means one. A unit vector is simply a vector with a magnitude of 1. I is the unit vector along the x-axis. J is the unit vector along the y-axis. So collectively, this represents the value of the x component of f1, and this is the y component of f1. So that's how you can express a force vector in its component form. Now, let's repeat the process for the other force vector, f2. So let's calculate the x component of f2. So that's going to be f2 times cosine theta. f2 has a magnitude of 300 newtons. Now, this is the reference angle. What we need is the angle relative to the positive x-axis. So we know this is half a circle, which is 180. If we go back 45, we get 180 minus 45, which is 135. So that's the angle relative to the positive x-axis, which is what we want to use. Now let's go ahead and plug this in. 300 cosine 135. So this is equal to negative 212.1 newtons. So that's the x component of the second force vector. Now you might be wondering, why do we have a negative sign? The reason why it's negative is because the x component is negative in the second quadrant. These values are negative x values. And so that's why we're seeing a negative sign here, which is good. This is an indication that we're on the right track. Now let's calculate the y component of f2. So it's going to be f2 times sine theta. And so that's 300 newtons times sine 135. So if you plug it in, this time you're going to get positive 212.1 newtons. And we can see why it's positive, because the y component is going up it's above the positive x-axis. Y is positive in quadrants 1 and 2. So now we can write F2 in component form. We could say that it's negative 212.1 I plus 212.1 J. So now that we have F1 and F2 in component form, we can add them to get the resultant vector in component form. So the resultant vector is going to be the sum of F1 and F2. So what we're going to do is we're going to add the x components together, and we're going to add the y components together. So it's going to be 173.2 plus, let's put this in brackets, and then negative 212.1. And this will give us the x component. Now we need to add the y components together. So we have 100 plus 212, and then times the unit vector j. And let me not forget 0.1. So 173.2 plus negative 212.1, that's going to be negative 38.9 times the unit vector I. And then we have 100 plus 212, so that's 312, and then times the unit vector j. So this is the resultant vector in component form. Now I'm just going to rewrite it to conserve space because I need to make a graph soon. Now that we have the resultant vector in component form, you might be wondering, what do we do next? What's our next step? Well, the next step is to draw a graph. So let's plot this value first. Now that's the x component and it's negative, so we're going to travel approximately 39 units to the left. So we'll put negative 38.9. Then this is our y component. It's relatively large compared to the x component, so we're going to travel positive 312.1 units above the x-axis. And this, the hypotenuse of this triangle, is going to be the magnitude of the resultant vector. And this is going to be our reference angle, the angle inside of the triangle. Now, to calculate the magnitude of the resultant vector, we simply need to calculate the hypotenuse of the right triangle. And if you recall the Pythagorean theorem, let's say this is A, that's B, that's C. We know that A squared plus B squared is equal to C squared. So C, the hypotenuse, is equal to the square root of A squared plus B squared. So we're going to use that same formula to calculate the magnitude of the resultant vector. It's going to be the square root of the x component, negative 38.9 squared, plus the y component, 312.1 squared. Now let's go ahead and plug this in. So for the resultant vector, I got 314.5 newtons. So that's the magnitude of the resultant vector. That's the first part of the problem. The next thing is we need to calculate the angle. To find a reference angle, take the arc tangent of the y component divided by the x component. And don't worry about the negative sign. We're going to make everything positive for now. If we keep it positive, we're going to get the reference angle inside of the triangle. So arctangent 312.1 divided by 38.9. And if your calculator is in degree mode, you should get a reference angle of approximately 82.9 degrees. So that is the angle inside of the triangle. Now what we need is the angle relative to the positive x-axis. So it's going to be 180 minus the reference angle we just calculated. And so that's going to give us 97.1 degrees relative to the positive x-axis. So now we have our answer. So we have both the magnitude and the direction of the resultant vector. So we can say the resultant vector has a magnitude of 314.5 newtons, and the direction is 97.1 degrees from the positive x-axis. That is, going counterclockwise from the positive x-axis.